We're going to start the basics of combinatorics, which basically are counting techniques. The first one we're going to go over is what is called the multiplication rule. I have k steps in an experiment. It's an experiment where I'm following one thing with another thing with another thing. It could be dice rolls, card choices, coin flips, and there are n1 ways to do the first step, n2 ways to do the second step, and so on. So ni ways of doing the ith step. Since I am following one after another, this is sometimes referred to as the matching principle, I'm going to simply multiply the number of outcomes in order to determine the total number of outcomes. So it'll be the product of all of the individual outcomes. We want to put n distinct objects in order. That means objects that you can actually tell apart. So in order to do this, we'd say, how many ways can I select the first object? Well, that would clearly be n. Now that there's one removed, there would be n minus 1 ways to choose the second object, n minus 2 ways, and so on until I get to the last 3, 2, and then 1 object. So if I'm putting these in order, then there will be n ways of doing the first one multiplied by n minus 1 times n minus 2, and we can see all the way down, we recognize this total as exactly n factorial. So the first counting rule that we have beyond the multiplication principle is that there is exactly n factorial ways to put n distinct objects in order. Now let's suppose you want r of them where r is less than or equal to n. So I want to choose not all of them to put in order. So in order to do this, I'd do the same idea. I would have n times n minus 1 times n minus 2. I need to select r of them. That means I will get to the point where I am n minus r plus 1. Now, in order to multiply this total right here, that could be rather long and rather tedious, especially if n and r are both large. But if you notice, this isn't a factorial, but the next integer in line here would be n minus r. So if I multiply this total by n minus r factorial over n minus r factorial, then my numerator and denominator will both be factorials. In fact, I would have the quantity in the end here, n factorial over n minus r factorial. We define this to be the permutation of n objects chosen r at a time. Write the word. The word permutation literally means arrangements. So that means I'm putting things in order. Okay? So that's your word for the day.